This is the sequence naming and equation writing video to help you understand what these sequences are now that you've completed their patterns. So, in looking at your piles of cutting apart these sequences that you were asked to do, like taking these and cutting these apart and so on, you should have ended up with 4 piles. The 4 piles should essentially be the 4 piles that I have listed here. Technically, you should have a pile that's kind of linear, where they're adding or subtracting the same thing, a pile that's more exponential, one that's more of a quadratic group, and one that's a Fibonacci group. Now this Fibonacci group is that oddball one that goes 1, 1, 2, 3, 5, 8. That's a goofy one. I know some of you might have struggled to figure that one out. That's because it takes these two numbers, adds them together to get the next one. These two numbers added together to get the next one. So that's kind of an oddball sequence. Don't worry about that one. The ones that you do need to worry about are the top 2. Today you're going to be writing the equations for both of these kind because they have a special sequence name. The name of those sequences are, if something is following a linear pattern, adding or subtracting the same thing, we call those arithmetic sequences. So this is a term that you want to write down. If they are exponential, where they're multiplying over and over, we call those geometric sequences. So arithmetic and geometric are the key words of the day. The ones that are the quadratics, those have like x squareds in them, and they're going to parabola, and you don't have to worry about the Fibonacci one. Now here are the letters of the sequences. In this pile, you should have had 3 of them. You should have had letter A, letter D, and sequence letter F. And then this one, you should have had 4 of them, B, G, H, and J would be the 4 sequences there. And then the quadratics were C and I, and then E was kind of that misfit with the Fibonacci. So now with those 7 sequences that you're able to do, you should be able to write the equations for these 7, because we've talked about this already, that all you need is what it starts at and what it goes by. You can write the equation for anything. So I'm going to have you write all 7 of these equations in just a minute. But first, let me explain how to do that. When you have an arithmetic sequence, the first arithmetic sequence you learned as a kid was 2, 4, 6, 8. Who do we appreciate? You can clearly tell that it's adding by 2 each time. So it's adding 2, it's adding 2, it's adding 2. One thing you don't know about sequences, and this is your time to learn this right now, is that this is the first term of the sequence. It's the first number of the sequence. This is the second number. This is the third number of the sequence. So in order to write the equation for it, you actually have to go back to the 0th term of the sequence. What number would be sitting here across from 0 that you could use? We'll go back to, because if you're going forward plus 2, that would be 0. So this equation is a sequence, so we use T of n, which stands for term number and number, is equal to, this thing starts at 0 and we add 2 each time. Now most people leave the 0 out, and it's T of n equals 2n is the best equation. For the geometrics, we've done some of these in that y equals a times b to the x form. It's going this way, timesing by 3. Timesing by 3. If you can't tell that it's timesing by 3, you can always take the next number divided by the previous. So what I mean by that would be you could take 18, which is next, divided by 6, which came before it, and you can get 3. So I can see the pattern is 3. So if I divide by 3, because this is term 1, this is term 2, I need the 0 term of the sequence, because whatever's across from 0 is the initial value or what it starts at. I divide 2 by 3, that would be 2/3. So this equation would be T of n equals 2/3, because that's what it actually starts at. Then it multiplies by 3 every time, and it's exponential, so the n goes up top. So this would be our equation for that geometric sequence. Remember, those are that a times b to the x format. And this would be the equation of that arithmetic. So in going back and looking at these sequences, A, D, F, B, G, H, and J, you need to write the equations for them. So I've got them listed down here that these are the ones you need equations for. So I'd like you to pause the video now and come up with those equations. In a moment here, I'm going to put up the answers. So pause now. And here are the solutions now that you've had a chance to work. They should be this. These are the answers or the equations that you should be coming up with for the 7 different types of sequences. Now that you've got that finished, you should be pretty good at writing equations for these. Next, I would like you to complete this in-class worksheet. Okay, the in-class worksheet is something that looks like this. It has 10 sequences on it, and your job with these 10 sequences is to be able to tell me if they're arithmetic, geometric, or neither, something else. So you just need to continue the patterns or think about what the patterns are doing and name them as being arithmetic or geometric. If you want to pick a few and try to write the equations for them, that will also help you really understand what you're doing. And then once you get that finished up and turned in, your assignment is 2 targets, targets numbers 1 and 3, and then the online homework in homework space for chapter 2.